All right, so we are moving on to session 2 for lesson 18, and we're still going to do some more practice with fractions. Again, this lesson is kind of like a really just a mini lesson to help you understand that fractions and division are completely related to one another. So today we'll dive in more into how improper fractions and fractions of mixed numbers are related as well. Let's show that with the warm-up. So we have two fractions here. We have 7/4 and 14/4, and it wants to locate each of those on a number line and then write them as a fraction as a mixed number. So let's keep that in your head. 7/4 and 14/4. Here's our number line here. Right here is 7/4, and over here is 14/4. So you also see in green these whole numbers up here at the top. So, and that's where we get our mixed numbers from and how they're equal to these improper fractions. Again, let me put that down here. All right, so that's just a term to remember. For tomorrow's lesson, we'll work on converting between the two. I'll show you the mathematical way, or you can maybe use a number line as well, depending. But so 7/4 means it's greater than 4/4 here, which is 1. And then I've got 1, 2, 3/4 after the 1. So 7/4 equals 1 3/4. We do the same over here. We've got, that's not right what I was doing. So I've got my 3 here, 3 wholes, and that's the equivalent of 12/4. So 12 divided by 4 would be 3. And then I look, I've got 1, 2, so 12/4 would equal 3 because it's at least up to that whole number of 3. And then it's 2/4 after, and we know we could reduce 2/4 to 1/2. So again, this is just showing you the connection between the improper fractions and our mixed numbers. All right, so our lesson starts on page 379. And let's go in and work on that right now. So Jared, Monica, and Heather. So we've got 3 people. In fact, let's circle that. And let's put a number 3 next to that. That gives it a number. Have 5 hallways to decorate for the student council. If they share the work equally, how much will each student decorate? For this example, we're just showing the basic setup. So we've got 5 hallways. And the work is being divided between 3 students. And again, this is practice in turning a division problem into a fraction. And it's like reading it from left to right. 5 hallways, 5. Our division symbol means divided by, and 3. So each student is going to get 5/3 of a hallway to decorate. And as we'll move into later in the lesson, 5/3 is also equal to 1 2/3. That's our mixed number. Here's our improper. And here's, I'm just going to call this mixed. And they're the equivalent to each other because if you look at 5/3, you know you can get at least 1 whole out of 5/3. You remove 3/3 from it, and then you have 2/3 left over, and that's how we do that. You can do those in your head, or I can show you the way to do it on paper. That helps too. All right, let's turn the page. And for this first example here under picture it, says you can use fraction models to show how each student divided up their work. So it's like we literally have the 5 hallways here, and then each one's divided up into thirds. And you could also think of it this way. So let's Jared, let's talk about his. So he gets 1/3 of each hallway. And if we add up all those thirds, we get 5/3. So that's where we get, that shows you that connection of dividing 5 hallways between 3 kids. And then down below in model it, the number line is numbered from 0 to 5 because there's 5 hallways. That makes sense. Here's 0, 5 total hallways. And you can divide it into thirds. And what you can do is they can rearrange all of the Jared ones, which are red, and Monica's blue, and Heather is green. And you notice down here they've just kind of squished everybody together there. And that's 5/3. And Heather's is 5/3. So it just shows that all of those can be pushed together and shows that they all equal the 5 hallways. So again, different techniques to find the same answer. Let's look at the notes. Not a lot of room to work here, but let's go for it. How many thirds of a hallway are there to decorate in 5 hallways? So each hallway is split into a third. So 5 hallways times 3 is 15 thirds total. How many thirds of a hallway will each student decorate? We know there'll be 5 thirds, right? This is a fraction of a hallway. So 5 thirds, just like that. Write a division equation that shows the quotient is a fraction. So that would be 5 divided by 3. Write a multiplication equation to check this equation. So if we multiplied the 3 people times their 5 thirds of a hallway each, that will give us 15 thirds. And 15 divided by 3 is 5, so that checks out. How many whole hallways can each student decorate? They each can decorate a whole hallway by themselves. And then how many hallways remain after they're done? 2 whole hallways. And then they can split up each of those remaining hallways into 2/3. So that's why each kid gets 1 2/3 hallways. You see that connection? Oh, and that's literally the next one. And that is 1 2/3. Calculate using remainder notation. 5 divided by 3. So this is not something I'm going to push hard to use, but 5 divided by 3. And this might be as simple as one of your first problems of doing division with remainder. 5 minus 3 is 2. So it's 1 remainder of 2. And that's what we write over here. Compare this answer to the mixed number. How are they alike? Well, it's simple as this. Your quotient is the whole number. And then your fraction let me do this a different color, are the remainder over your divisor. So instead of writing all that out, I'll just show you there. So let's say this is the quotient equals the whole number part. And then I'm going to put remainder over the divisor. Now that'll come in handy for tomorrow. How to write division. That'll come in handy for tomorrow's IXL assignment. There. How does the bar in a fraction represent division? Let's not even talk about that. Not necessary. Anyway, here's everything you need to know as far as that goes. Let's practice some. Turn the page. All right, look back at your try it strategies by classmates and picture and model it. It's ones we just all talked about. Which models or strategies do you like best for finding fraction quotients? Explain. We're not going to do that one. Skip that one. Okay. 5 friends are equally sharing 3 packs of football cards. How exciting. I used to do the same thing. But we kept things easy. If we had 5 friends, we'd buy 5 packs of cards. But we were not fraction superstars like us now. So how many packs of cards will each friend get? So there's less packs in our kids, so everyone's going to get a fraction of a pack. It wants to use a visual model, so let's do that. So I want you to draw 3 long rectangles, and each of these is going to represent the pack of cards. Now, we can get really deep and complex and ask how many cards are in each pack, but we're not going to worry about that. So there's 5 kids. So each pack, you can think of it this way, each kid is going to get a fifth of a pack. So if you draw 4 lines on this model, you'll split it up into 5 parts, just like that. So let's go with kid 1. Kid 1 gets 1/5 of pack 1, 1/5 of pack 2, and 1/5 of pack 3. And if we add those up, each kid will get 3/5 of a pack of cards. And that's how you can use a visual model to do it. So there's that. Let's go on to the next problem. Elena made 10 ounces of apple chips, which are pictured there. I thought they were potato chips. I was wrong. She puts the same amount of apple chips in each of 4 containers. How many ounces of apple chips are in one container? So the grand total of stuff is 10 apple chips, and she wants to divide it equally between 4 containers. So this quite simply is going to be the 10 chips divided by the 4 containers. And let's see, they want us to write a division expression and write the solution in remainder form. Okay, so over here, we've got 10 chips divided between 4 containers. I can 2, and I get a remainder of 2. And write the solution in remainder form and as mixed numbers. So here's remainder form, 2 remainder 2. But we want to write this in a different way. So the mixed number, so let's put, we know a mixed number, the quotient is a whole number. In fact, let me do this. Quotient's the whole number, which is this right here. The fractional part of the mixed number is your remainder over your divisor. And 2 2/4, or we know 2/4 is 1/2. So each container gets 2 2/4, or 2 1/2 ounces of chips. And this is a good question. I'm not going to skip this. Does a remainder form, which is this, or the mixed form, in fact, let me do this remainder. Which form of the mixed number form best answers the question? Well, if I'm cooking or if I'm in the kitchen or I'm dividing things up, especially if I'm talking about ounces or cups or whichever, or pounds, I'm not going to say 2 remainder 2. I'm going to use the mixed number form. That's just, it makes more sense. And that's more of something we can use for actual measurement. And let's do the last one. Which expression is equivalent to 12/7? Well, let me show you how to read a fraction out loud or in your head. That makes it really simple to do this. So you've got the 12. Instead of that line that we usually do, replace it with the phrase divided by 7. So 12 divided by 7. This is 12 minus 7. This is 7 minus 12. This is 7 divided by 12. and this is 12 divided by 7. So again, when you see this line right here, in your head, almost think of it as the phrase divided by. Because remember, your fractions are actually, or your division symbol is actually visually representative of a fraction. All right, so IXL is going to be K2, fractions of a whole word problems, but these also use visual models, and you're basically going to be reading over the word problem, the scenario, and then creating a fraction for it. Again, the more basic practice fractions, the better. And then tomorrow we will do converting between mixed numbers and improper fractions. So we'll kind of bring all that together. But this is a nice making sure everyone understands the bare basics of fractions before we move on to that. All right. Let me know if you have any questions.